Good morning to all. So today the concept is total probability. So first we need to define the total probability. Consider a sample space S that has n mutual exclusive and exhaustive events Bn, n equal to 1, 2, 3, and so on n, such that Bm intersection Bn equal to null set, m equal to n equal to 1, 2, 3 and so on n. The probability of any event A is defined on this sample space can be expressed in terms of the conditional probabilities of an event Bn. This probability is known as total probability of event A. So total probability can be understand with the help of some examples. For example, if you take two boxes, in two boxes it will be hanging two different color balls, that is a red color ball and white color ball. So what is the probability of getting a white color ball? For example, now I am going to pick a one ball from the boxes. I don't know which box I am going to be select. Just I am going to be take a ball. Just I am going to be pick a ball. So what is the probability of getting a white color ball from the two boxes? So at that point we can be apply the total probability. Okay, so that is the meaning of the total probability. So mathematically, so this formula defines the total probability. P of A equal to summation n equal to 1 to n P of A by Bn into P of Bn. Proof. Let us consider Venn diagram contains event A and n mutually exclusive events. From the Venn diagram, so from this is a Venn diagram. From this Venn diagram, so B1 intersection B2 equal to null set and B2 intersection B3 equal to null set, Bm intersection Bn equal to null set, where here m and n are not equal, that is equal to 1, 2, 3 and so on up to n. So from Venn diagram the sample space can be represented as S equal to B1 union B2 union and so on union Bn, that is equal to union n equal to 1 to n Bn. So this one I am representing as equation number 1. Let the event B is defined on the sample space as given in the equation 1. Here, so here A is a subset of S, then A intersection S equal to A. So this one I am taking as a 2 from equation 2. So A equal to A intersection S. So in next one I am going to be substitute equation 1 in equation 3. So substitute equation 1 in equation 3. So I will be getting A equal to A intersection union n equal to 1 to n Bn. Means here you will be having a set of union events of the union operator. Therefore A equal to, so union n equal to 1 to n of A intersection Bn. So this one I am taking as an equation number 4. Now apply the probability on both sides of equation 4. So I am applying a probability on both sides. So by applying the probability you will be getting a P of A equal to P of union n equal to 1 to n of A intersection Bn. Therefore probability of A equal to union n equal to 1 to n P of A intersection Bn. So I am taking this one as equation number 5. Since the event P of A intersection Bn and P of A are mutually exclusive, so apply the third axiomatic approach. So probability of A equal to summation n equal to 1 to n probability of A intersection Bn. So this one I am taking as an equation number 6 from the multiplication theorem. So as we know that multiplication theorem, probability of A intersection Bn equal to probability of A by B into probability of B. So this one taken as an equation number 7. Now this equation 7 I am going to be substituting equation 6. Substitute equation 7 in equation 6. So after substituting I will be getting probability of A equal to summation n equal to 1 to n probability of A by Bn into probability of Bn. So this one I am considered as an equation number 8. Hence we have proved the total probability. So now problems. So first, two boxes are selected randomly. The first box contains 2 white balls and 3 black balls. The second box contains 3 white and 4 black balls. And what is the probability of drawing a white ball? Okay, here what they have told, two boxes are there, so randomly you are going to be select a particular ball, and what is the probability that it was white color ball. So solution, assume that the two boxes have equally probabilities of being selected. The probability of selecting the first box is equal to the probability of selecting the second box B2. Therefore, probability of B1 equal to probability of B2 equal to 1 by 2, that is equal to 0.5. So given the favorable events is selecting white color ball from the box B1. Therefore, probability of W by B1 equal to 2 by 5, that is equal to 0.4. The favorable event is selecting white color ball from box B2. So therefore, probability of W by B2 equal to 3 by 7, that is equal to 0.4285. So using the total probability theorem, so probability of W equal to probability of W by B1 into probability of B1 plus probability of W by B2 into probability of B2. So now by substituting that value, so you will be getting finally probability of W equal to 0.4143. So this is the probability of getting a white color ball from the two boxes. So second problem. In a factory there are 4 machines. The machine produces 10%, 20%, 30%, 40% of an items respectively. The defective items produced by each machine are 5%, 4%, 3% and 2% respectively. Now an item is selected what is to be defective. So solution, given data. In a factory there are 4 machines which produces an item. Let M1, M2, M3, M4 are the events of producing an item by the 4 machines respectively. The probability of producing an item by the machine M1, that is probability of M1 equal to 10%, that is equal to 0.1. The probability of producing an item by the machine M2, therefore probability of getting a product from the machine M2 equal to 20%, therefore 0.2. The probability of producing an item by the machine M3, so the probability of M3 equal to 30%, that is equal to 0.3. Probability of producing an item by the machine M4, that is the probability of M4 equal to 40%, that is equal to 0.4. So let D be an event to producing an defective item. Given the probability of producing a defective item by the machines are, the probability of producing an defective item by the machine M1, that is the probability of D by M1 equal to 5%, that is equal to 0.05. The probability of producing a defective item by the machine M2, therefore probability of producing a defective item from the machine M2, that is equal to 4%, 0.04. Probability of producing a defective item by the machine M3, therefore probability of a defective item from the machine M3, that is equal to 3%, equal to 0.03. Probability of producing a defective item by the machine M4, therefore probability of D by M4 equal to 2%, that is equal to 0.02. Using the total probability theorem, the probability of selecting a defective item is, so this is a formula of the total probability, therefore P of D equal to P of D by M1 into P of M1 plus P of D by M2 into P of M2 plus P of D by M3 into P of M3 plus P of D by M4 into P of M4. So that is equal to 0.1 into 0.05 plus 0.02 into 0.04 plus 0.03 into 0.03 plus 0.4 into 0.02. So at last you are getting the probability of getting a defective item from the 4 machines, that is equal to 0.03. These are the final answers. The probability of producing an item by the machines. So this is the probability of producing a defective item by the machines. And the final answer, that is the probability, the total probability of getting a defective item from the machine, that is equal to 0.03. Okay, in this section, so we have studied or we have learned the concept of total probability. So what is meant by total probability? Total probability is nothing but that we are going to be select a particular color ball from the 2 or 3 boxes. So at that portion we need to be apply the total probability, and we also solved some problems on the total probability in order to understand the concept of the total probability. Okay, and thank you.